All right, guys, here we go. So note, if you will, we're going to learn the Fundamental Theorem of Calculus.
That sounds important.
Sounds a little bit important.
What the heck is happening?
Yeah. Okay. So the Fundamental Theorem of Calculus. And basically, as I was telling you yesterday, guys, if we took some function and we look at it over an interval, a to b, we can actually calculate the exact area of this function using calculus. And it's pretty cool. Pretty crazy that you could take something with curves and we can do it. Usually we do rectangles, length times width. That's doable. With this, we can take an imprecise thing and we can get the exact area. Here is the theorem. Fundamental Theorem of Calculus states that. I'll give you the technical definition, then we'll explain it in English. If a function, this is right on page 275, guys. If a function is continuous on the closed interval a to b.
I did that.
So if a function is continuous in the closed interval a to b, and f, big F, is an antiderivative. What's antiderivative mean? It's opposite of derivative. Integral, right? Exactly. Of f on the interval a to b. Sure, you got it. It's right on the book on that 275, I think. Then, and here's the theorem. Here's the theorem. Integral, and this is actually, it's easy. From a to b of f of x dx is equal to big F of b minus big F of a. All right, so write that down, and we'll talk about it. Here we go. I don't have a good spot for this thing.
Wait.
Oh well. Shannon, is it?
Is it in your way, Shannon? Really?
Is this in your way? Okay, cool. And you're good with it, Christian?
It is now.
Yes, Justin.
Tell me when it's not in your way. Sure.
Well, I need to.
You need
Oh,
it.
I need to. I'll let you in. Casey, you
Because
can go
when
here.
we came in, we had to move this way because it was like pitched up on us.
Oh, I see. Here, let me just throw it right here in that corner. You don't mind?
Yeah, we can move the tables back.
Okay, cool. This is fine. This is perfect. Right here is perfect. As long as you look. We're good. As long as you look and see. All right, so guys, good? So let's talk about this. Here's my function f of x, right? Right here is my function f of x. Basically, if we want to find the area under the curve, all we got to do is integrate f of x and then evaluate that integral at b and evaluate that integral at a. And then take that and take the second one and subtract it from the first. So evaluate the integral of b and then subtract the integral evaluated at a, and then boom, we're going to have that area under the curve.